Okay, so now we're going to talk about making corrections. We're going to make corrections on both 1.1 day 1 and 1.1 day 2. I'm just going to walk through a couple of problems that I saw more than a few people had some issues with. That's usually how I run my corrections. Corrections ordinarily will be made the day following an assignment. 1.1 day 2 was given on Thursday, so this is technically the day following an assignment, the in-person or in-class day. And sometimes I'll do this as a Google Meet rather than doing it on a slide like we are today. The exception to the corrections would be a day after an assessment. Assessments are worth a lot of points. They're worth 50% of your grade for a test, and a quiz would be worth 30% of your grade. Those are big deals. And when I do correct those, I want to make sure that I give you some feedback on them so that you have an opportunity to go in and make corrections for credit back on most tests. And some quizzes I'll let you do the same thing for. It depends. The quizzes are generally exit tickets, so typically I don't have you do corrections on those. But for sure on tests, because I don't want a test to tank anybody's grade. So we want to make sure that you get the feedback you need, the clarification that you need so that you can make corrections. Then I will today go over some of the questions that I found many students struggled with in both 1.1 and 1.2. And the reason I only go through a few of the problems is because Big Ideas does give you the opportunity to see if your answer is correct or not. So if you enter in an incorrect answer, it's going to tell you it's not correct, and you should go back and find your error and try to fix it. I can also see when you turn in your loose leaf on Google Classroom what your errors are as well, and then I can go in and correct those misconceptions for people in class. So you should be able to use this information that Big Ideas gives you to self-correct your answers. So you really don't need me to help you that much. In addition to Big Ideas giving you the chance to self-correct, you can always go back and watch videos on Big Ideas on how to make those corrections. So there's a lot of opportunity here that you can do without asking me. You can do it right on the spot so that you don't forget what your questions are. Let's start with day 1, 1.1 corrections. The two problems I noticed most people had trouble with were number 5 and number 8. Number 5 had to deal with the pi symbol, and maybe that's what's throwing some people off. Remember, pi is just a number that we use a symbol for because it's too large, it's irrational. We can't write the entire decimal, so we use the pi symbol instead. So this says a number x minus 8 pi equals 1 pi. So we need to know what this number is. If I subtract 8 pi's from it, will give me 1 pi. So in order to do that, I need to isolate the variable, the x. And this says minus 8 pi, so I'm going to add 8 pi's to both sides. When I add 8 pi to both sides of the equation, because I'm using the equality property of addition, I end up actually losing this the side of the equation. Only thing I have left is the x, because 8 pi's minus 8 pi's is 0 pi's. And then on the other side of the equation, I actually have 1 pi plus 8 more pi's. Altogether, 1 pi and 8 pi's give me 9 pi's. So my answer is x equals 9 pi's. So let's take a look at our answer and see if it makes sense. If I have 9 pi's, no, it's really difficult for me to draw this way, but I will. If I have 9 pi's and I take 8 pi's away, 9 pi minus 8 pi leaves me 1 pi. So that would make sense if you had done this and done the correction yourself to see if your answer was correct, or checked it, I should say. You would have seen that that was the correct answer, 9 pi's. All right, question 8. Solve the equation. Well, 3/8 equals a number plus 2/3. I see a lot of issues here. I'm dealing with fractions. I'm dealing with fractions that don't have a common denominator. So the first thing I'm going to do is I need to isolate my variable. I need to rewrite my equation. So when I rewrite my equation, that's when I realize, you know what? I've got a lot of stuff going on here. I've got to find what I actually put in here. Here we go. I've got no common denominator, and I need to subtract 2/3 on both sides of this equation. When I subtract 2/3 on this side, I get 3/8 minus 2/3 equals R, because these 2/3 cancel each other out. Positive 2/3 plus negative 2/3, they cancel out, they make 0 2/3. So I just have my variable R left over. But because I don't have a common denominator, I have to find one. And the common denominator of 8 and 3 is 24, which means that I need to multiply the numerator in the 3/8 and the denominator by 3. And the 2/3 equation or fraction, I need to multiply both the numerator and the denominator by 8. So I end up with 9/24 minus 16/24. Okay, so that's my problem now, and I need to, they're both opposite signs. Add the opposite, I would get 9 plus negative 16, which is negative 7/24. And that is the answer to that equation. Now, that's what would go in here. Negative 7/24 plus 2/3, which we already determined was negative 16/24. If we add the opposite, we would get negative 7 plus positive 16, which would give me 9/24, which reduces to 3/8. That's a long way to go to get that answer. What could you do if you did not know how to do a common denominator? You could plug this into your calculator to find out your fraction. All right, and that would have helped you a lot. All right, 1.1 day 2. 1.1 day 2, I noticed that number 4 and number 8 were problems for people. Again, number 4 has to deal with the pi symbol, but it also has to deal with division of a to isolate a variable. This says a number divided by pi is 7 3/10 or 7.3. How I undo division is to multiply. Well, this should be undo multiply. It should say undo division by multiply. Let's get rid of that. That's wrong. Undo division by multiply. Okay, now it's right. To undo division by multiply, I need to multiply both sides of the equation by the denominator. The denominator here is pi. So what does that look like? Pi over 1 times m over pi. There's my m over pi. And notice I multiply the other side by pi as well. What happens here is another cancellation. Pi over pi ends up being 1, and this cancels out. So I end up with just the m on one side and 7.3 pi on the other side, and I'm finished. If you wanted to go into your calculator and put 7.3 pi equals 7.3, it would give you the same answer, just 7.3. So that is the value of m. Notice that it just, all we did was take away the pi. That's all we had to do to solve that one. Okay, and question 8. Question 8 is very complicated because it says -2 is 6/7 of a number, or 6/7 times a number p, a number we don't know. So we need to isolate the p. And here, this is multiplication. We need to undo multiplication. I want to get rid of that one because I don't want to confuse anyone. By dividing. And remember, when you divide fractions, what do you need to do? Keep, change, flip. We need to keep, change, flip. So we need to keep the 6/7, and we need to multiply by the reciprocal of 6/7, which is 7/6, both sides. 7 over 6 times -2 over 1. I have to make my whole number into a fraction. And on the other side, 7/6 times 6/7, which we know equals 1. These two together are their opposites, and whenever you multiply fractions by their opposites or number by their opposites, they go away, or in this case, they equal 1 because it's a fraction. So then I just multiply numerator times numerator, denominator times denominator, and I get negative 14/6, and that is the value of P. Now, there might be some issues with Big Ideas taking negative 14/6 as an answer. You could turn it into a mixed number, okay? Or maybe your calculator gave it to you as a mixed number. And this isn't even a reduced mixed number. This would be the actual reduced mixed number. I think this is what Big Ideas was looking for. But guess what? When I go in and I correct Big Ideas, I look at your answer. And if I saw this in anyone's answer, I gave you credit for it. So it's all good. Big Ideas might not let you put it in, and you might be certain you're right. And then I might go in, especially in a fraction like this, and give you credit for it. Okay, so those are your corrections for today.